In addition, we lost one holiday, but that's what it is, and I gotta keep moving. Most of you have given me, there have been a couple of emails this morning. I have not checked everybody's submission. I I think majority of you have already given me Project One report. This is what I will do with Project One report. I've already scanned all the toolpath files that was submitted originally. I am going to show you, not today, next week after I read all your reports, as to the common observation that I have made with many different toolpaths. I can tell you upfront for Project 2, make sure you click on the depth of cut. And depending on the tool, majority of the tool is 2 millimeters maximum, except the smallest tool, which is the 1/16th, which will come into play in Project 2. You should limit it to only 1 millimeters. It's a very thin tool and will easily break. Plus, I said up at the front while you're going through Project 1 that we would be changing the tools. As a result, the tool library will change. No, the tools are not going to be updated. So you still have access. If you have already started, I'm sure you have started Project 2. Some of you, I know, are putting in tool paths. The tool numbers will not change. Tool 1, Tool 2, Tool 4, Tool 7, Tool 8, and Tool 10. The depth, which is the cutting length, I've now given you an updated. So 25, 9, 37, 2, 43, and 19 are the cutting length of the tool. So all these depths will be quite adequate for your Project 2. It's not going to limit at all. If it was Project 1, yes, but not in Project 2. I've also am giving you the overall length, 34, 27, 43, 54, 60, 40. The overall length must be greater than the cutting length. And it is what it is. And the last column is the maximum depth of cut. 2, 1 can go full, which is the drill. The face mill, 2 millimeters maximum. It can cut more, but your part will probably be broken from the vacuum because of the excessive force. So we are not hard clamping, we are holding it with the vacuum. That's why some of these limitations come. In fact, for a HDP and the foam, we can cut greater depth, but I don't want to do it. Everybody should follow the same. That's why, that's the reason why I put this up, so that we can compare your tool usage time. Now, the cutting length will come into play how deep you cut. The overall length is brought in only during simulation. If you saw the tool take away some of your already pre-cut part, it's because of the collet chopping already finished material. Basically, the overall length was not right. I wouldn't say was not right, was with respect to previous tools. So now I've updated. If you update this during simulation, you will not see collision. So this is the only update you have to do. Then I also want to make sure everybody stays with the same feed rate of 1000 millimeters per minute and a spindle speed of 4000 RPM. how do we make sure all the information that I have given here is going to be correctly used by you? Very easy. Don't go and touch the tool library by modifying all this. As you bring a tool into a contour or a pocket or a drill or whatever, after you finish, if you click on the tool on the left-hand section of the operation library, if you double click on the tool alone, a new screen will come up where the first page will allow you to input the cutting length and the overall length. You can type it, okay? And you can also check the feed rate, because what I have noticed in the project one submission, I am not sure how this got in. For some people or some members, the feed rate has changed. Sometimes, most of the time, significantly less, especially the plunge when you're helixing inside. I see 0.038, something like that, which is making it very, very slow to get into the part, which will affect the machining time. If you have multiple layers, every time it's going to slow down before actual cutting starts. So I will go through this. This is good enough for you. This is already in D2L. I put it in this morning. So if you have already created the toolpath, no big deal. Nothing is wasted. Okay. If you see in simulation, the collision, it's the result of overall length being shorter. Okay. So you can update it and recompile. That's all you need to do. You don't have to recreate the part from scratch. Okay. So I will go through this in the lab session. I don't want to open up a Mastercam right now because when I launch too many files open, something happens and something gets clobbered. So I don't want to open those, Mastercam file. Next week, after I have gone through all your reports, I'm going to give you a feedback in terms of individually using the report and collectively as to what all I have observed. For example, some people have used in the original submission, the first submission, using a bullnose tool instead of a flattened mill in project one, which is a no-no. So those type of, make sure you will be using only 1, 2, 4, 7, 8, 10. 3 is gone, 5 is gone, 6 is gone. So those tools are not really useful for this 2.5D mill. Okay, so that's what I want to bring to your attention. The second one, when I look at the calendar, your midterm break starts on the November 8th and ends on the November 12th, which is a Friday, of course. You keep going till the 14th, then you come back on the 15th. So you all know that this time we are going to be cutting solid 13 people individually, and I expect each machining to be at least taking both sides put together 20 to 25 minutes. So we need the lead time to check through your files. So I am asking you to give me the project 2 lamp base files, no report, on or before November 5th, so that we can go through all of them. Both myself and Dave will go through to make sure that you don't have any cuts that are going to ruin our vacuum table or break the tool or break your piece. by November 5th. Sooner the better, because if you submit a little earlier, I'm pretty sure many of you have already gone into project 2, creating toolpath. So you have this week and the next week, quite adequate to finish it. Okay, so that if you have the files, we can run them before we show it to you for you to make some corrections or whatever. The deadline for project 2 in terms of report, I have not announced it. Okay, I have the rubrics, which I would like to go through once more before putting it into the D2L. It will go to D2L before next class. Then you go through it and ask me questions. It's very similar to project 1, but with few more details asked for. Okay, so I'll do that tomorrow, submitting into D2L project 2 report requirements. Also, be aware that I will not be waiting for project 2 to be completely done before starting project 3. I will be presenting project 3 as soon as I cover 2 more lectures on the PLC side. Then you would be ready. Plus, I have to give you kind of a go through, like Mastercam, the PLC software, which I will do during the lab time. Now, I know for sure 12 out of 13 are able to do everything online, accessing whatever. I'm pretty sure you are not going to have much of a problem in accessing the WinLoader software, which is the PLC software. So during the lab today as well as Thursday, I'm going to ask you to remotely link and see everything is going well with the WinLoader software. If that goes through, it's much less computer intensive, unlike Mastercam, in terms of crunching the power of the computer. So Trevor has already tested. Unfortunately, Trevor did not include either myself or Matt or Dave into the loop of being able to log in. With good intention, he wanted to reserve all the resources for the students instead of us taking a space. So I can't check anything about the remote link by myself. But Trevor showed it to me that he can do it from his office exactly the way you would do on offline. But I'm glad all of you are on board with online. And the only one that I have a difficulty has to be resolved. Okay. So, any question? On my opening stuff? Okay, you may have a question about the impending strike, which the university is supposed to be negotiating the union. I am told it is not the university that is dragging their feet. It's the provincial government that seems to be a big pain. Provincial government simply has kept us. I don't care. I don't need any more salary increase. It's the junior people who are pretty badly affected. 4 years in a row, no salary increase, and they want to keep continuing when the inflation is 4.7%. Oh, and you know the results of the strike vote. Unfortunately, if something has to happen, it will affect people. But hopefully, they will straighten things out. Okay. So that's about what will happen to the course at that time. I have no clue at this point. Okay. So I'm going to close this. We have no question. Okay. Now I want to go. Okay, you should be seeing the new screen. I think I was somewhere here. Okay, this is the slide I was in, and I didn't complete the story. And let me complete the story before I move on. Okay, so I talked about the motivation for this problem. Let me move this out. Okay. Do you see the screen clear without any overlays? Yes? Somebody?
Yeah, we can.
Okay. So, I gave you this example for timer where a part is rolling down. Could be a cereal box, could be milk carton, and in this case, the case that motivated me to do this is the super value packaging line where ground beef, it's just not ground beef alone. It's chicken, several stuff that they were packaging right behind on a massive space allocated for food processing. It's no longer there. This operation is not done within Super Value anymore. So they package everything and bring it into the store. And I said they got caught. 16 cases of fraudulent practice, nailed for a $1.2 million fine. So the case was taken. Of course, two different law firms. One is representing the Crown, which is the government, and the other one is for Super Value. So it's a big law firm located downtown that was representing Super Value. So they approached the university and the faculty and the department, and I was seconded to go and see what is going wrong because it's automation. So I told you last week, upon consultation with the head of the department, a nominal $1,000 as consulting fee was given to the company. What a sucker I was. So I'm close to, I would say, 17 hours of videotaping the lines. I wasn't standing there, neither was my graduate student. We put the camera up because they were doing all these operations in the night. Record over the night at a slow speed and then bring it back to see what exactly is going on. The video revealed a lot of stuff. And then we had to find what exactly, analyze why the problems cropped up. So after 3 months of wrecking our head and looking into the whole stuff, about 8 different types of defects showed up. This is the problem. The operator puts it right here. Let me get my pen. Where did my pen go? Somewhere hiding. Okay, it's here. Okay, so parts are dropped here. The parts are dropped here. And this line is going at 30 feet per minute. No switching on off, it's continuous. When the operator pushes the button, the conveyor keeps going. So the conveyor has to pace with this 30 feet per minute. So quickly drop the ground beef, and the machine takes over, applies heat, and puts the saran wrap and heats. Why heat? To bind the saran wrap around the foam pallet. And it's moving. Okay, it comes here. The weigh station weighs the part as it is moving, so dynamic loading. Then when it comes here, there is no trap door. A barcode machine, based on the information that is got here, puts a label on top of the packaged meat. And it keeps going and then drops here into a big bin. So what was the problem for the double weight or whatever? When this is done here and the heat is applied on the saran wrap, the operator is already ready with another one built. So because this conveyor is dynamic, sometimes these two parts cling. Saran wrap, heat, they are bonded like twins. So they are traveling. The weight of the two is registered by the weigh scale. And as it goes here, the very first package that is underneath the barcode station gets a label with double the weight. And the one behind, which is clinging and attached, just leaves without a label, and the two drop here. So you have one package with double the weight, and another one no label. So the operator, who is not aware of what is going on here, sees two. It happens only once, maybe twice or thrice in a day. Who knows? They were caught for 16 times. So separates. One did not get the label. Separates the two and throws it back here. And then it comes back. This time maybe it's lucky. And then this is distributed. So the one with the double goes to the distribution. And that's what the person who reported got. Okay, and the federal inspector got 16 more of this. That's where the lawsuit came. It is not only ground beef, it's a chicken which also had problems, but totally different type of a problem, which Super Valley was not even aware. When it comes, there is a sweeper here which sweeps the pot over the scale. Okay, so what happens when the pot drops onto the weigh scale? You have a dynamic load, sometimes 1.2, sometimes 1.3 times of the actual weight due to dynamics being dropped or swept on top. And then this goes. So its base is the label that is generated is 1.2 times. That means you are paying for 0.2 times more of the price of the chicken, whatever. Right? Like this, there were 8 defects that I found. So based on this, I was asked to submit a report, and the report was about 135 pages long. I still have it somewhere in my library. And in addition to automation, I used a lot of statistics like occurrence sampling, level of confidence, and so on. Sometimes it's not taught in our programs. So true engineering analysis with stats brought in. So it was submitted by the firm that was fighting for super value to the Queen's Bench, and I was asked to come to answer any questions on my report. So I did go, and the first thing that the Crown lawyer tried to do, that I am an engineer and I shouldn't be saying anything about stats because I'm not a statistician. And I also embarked that based on my religion, I'm a vegetarian. I should not be speaking about beef. So basically, he was trying to overrun me and tell the judge that I was invited as an expert witness, that I should not be allowed, and my report should not be allowed to be brought in to the discussion. The judge said, well, I have read the report completely and I'm very impressed, and I am going to admit. So the prosecuting lawyer, the first question was, how much of statistics do you know? So I had to defend because I knew statistics. I took 2 courses. So I asked him in return some questions in stats to find out how well are you qualified to ask me questions about statistics when I believe as a lawyer you probably don't know anything at all. So there was a big laughter, whatever. Went on, and after 3 hours, the case was put to a rest. And then I didn't have to appear after that. Presumably, super value got away completely. And I met the lawyer who worked with me. He said, super performance, we got completely. What the recommendation was, it's automation being the first case. Super value was not aware of all the problems. So the recommendation is throw this line out and reinstall based on my recommendation where the operator can see. That's a couple of $1 million. Okay, so they were forced to implement that new stuff. But I heard from these lawyers that Super Value went after the company that supplied this to enter into a lawsuit against them. And I heard it is a company from New York which went bankrupt before these guys moved on, so they got away. So later on, I was told the Crown prosecutor came back again against Super Value because Safeway came up with some issues about it. But I'm told even that got thrown out. Then the firm that represented the Crown, I ran into them and they said, oh, we are very impressed with how your report went through. Would you help us in another case that involves a farm and something to do with how the cattle are fed and the cage that is designed, whatever. I did look at it from a geometrical perspective. Okay, so I have done something like this about 3 or 4 times in the area of automation. So here the moral of the story is, if you are designing or implementing automation, long ago the law was not clear. If something goes wrong, who is responsible? Now the law is clear. If you are a professional engineer and you implemented it, your neck is on the chopping block if something goes wrong. So that's what I want to convey. Now, it was an interesting experience for me. but was a lot of time. If I had known that's what was going to happen, and if I had known that's the fine that was being talked about, I should have charged a lot and should have retired by now to some big investment somewhere. Be done. Anyway, that didn't happen either. I like what I'm doing. Okay, so we are now going to move on. We talked about input, output, combinations of inputs being true, not true, an AND, an OR operation, and a NOT operation, generating an output. Are there more options? The answer is yes. The first thing I'm going to discuss is a latch. It's also called a reset because its latches are used for resetting outputs. Simple case, well, I want to turn on a motor and I have a pulsed switch. That means momentary on, which we have seen, discussed how it is used. I turned on the motor with that pulse switch. Okay. If I want to keep the motor going, even though I have released my hand, that means this input has become untrue. It was true, then it became false. If the logic is, if input is true, turn on the motor. If the output collapses, the motor will collapse. Not desirable. It's like the punch press I gave you as an example. You start and your hand is released. The punch press should come down all the way, not reset and go back, because the input collapsed. It has to go all the way until the advanced position is reached. So how do you do this? This is where the latches will start coming in. So what does the latch do? Let me take you straight to the ladder diagram and explain. So what we have here is an input B Something is blocking my screen. I'll move it out. Okay. We have an input B that sets an output. When I say now, I'm using a different word, set, which makes the output true, let's assume. But if B goes down in the traditional route, the output X will go down. I don't want that. Let B go down, but I want to keep the X going. How do I turn off this motor, which is the X? Use another input. I've called it as A, could be anything. To start the motor, A must be false. So this should be okay. This should be 0, and let this be 0 too. Nothing will happen to the motor. Motor is not running. This is at startup. Then I went and pressed B, make it 1. Then I released my hand. It becomes 0. So when it becomes 1, this was 0, becomes 1 during this phase, and will continue to be 1 provided A is 0. So A must be 0 to start with. B is to start with 0. Then don't touch A, only poke on B, make it true. The output X becomes true and will continue to be true even if B becomes 0. So this is acting like a trigger. Okay. Now let it run for some time or whatever time you want. Then you go and poke this and make this 1. everything is momentary. You just press. So let's assume this is the green button on the panel, and this is a red button to stop on the panel. You press this once, boom, X will collapse. So that's why it's called a latch. Okay, so pretty useful function in automation. Before I give you an example, I forgot to tell you about your midterm test. I am done, I would say 85 to 90%. I go question by question on all papers. So I finished question 1 in everybody's, question 2 in everybody's. I should be done with it tomorrow. Now, I made one mistake for sure. Question 1 was not worded very clear, expecting the clear answer I expected. So there have been n number, 13 different types of answers. So as a benefit of doubt, if you did not answer what was in my mind but is reasonable, I've still given marks. Now the question is, how do I give you the answer book back when I'm done? Last year it was online, so I corrected using tablet PC and then sent it back, the corrected version. Now the only way I can give you the book back quickly is to scan every one of your submission, midterm submission. That'll take me time scanning, probably 40 pages total, who knows, including the front question paper, but I'll do something about it. You will get it back, but I am going to email your marks first, followed by your question paper. Then next class I will also present the key to the midterm test as to what was in my mind expecting, and any reasonable answer, even though it might not be what I was expecting, has been given credit. Okay, so wait until Thursday to see your marks, and then if I get moving tomorrow with scanning, I might as well send it back to you. Okay, so that's the midterm stuff. Okay, now going back to this, give me an example of this type of application. Anybody? Where you will see the use of a latch. It's also called a keep. K-W-E-P. Latch, keep, they all mean one and the same. Okay, no example? Okay, here is an example. I'm into processing or packaging sand, cement, salt, cereal, milk, whatever. Okay, so something is happening here at this point where something is being poured into the bag or the carton, and I have a sensor here which is looking at this presence of the box, and then another sensor looks at when it is completely filled. Now this conveyor is stationary. Okay, then once box is present, let's call it as A, and it is full, A and B, and let's call this as a motor. I'm close to the area of my tablet. If A and B is true, turn the output M. So the motor will start moving and the box will be transported. Now let's assume this is not a very long conveyor, maybe 5 feet, short conveyor. Okay, so the box will keep inching away or moving fast and will come to this location where there is another sensor C, which is looking at the box having reached C. C reset M. Okay, so if I have to redraw this would be A and B, M as a latch. Okay, and C reset M to 0. This turns it 1. Okay. Now what happens if this box, let's assume, is being removed by somebody or some machine is taking it out? Stays here. Okay. This line, this position is free. So I can still continue to fill this box with whatever material. But A and B becomes true. What happens to C? It is still true. It has not been removed. The box is not removed yet. So this will latch and prevent the M from being triggered. That means the line comes to a stop. Right? Good or bad? Well, if it is only 5 feet and something has gone wrong here, start the line. But that's not the way a milk carton or whatever automated line will move. Well, it would be 100 feet and the transportation time will be a couple of seconds. You're not going to move them at high speed. Okay, they will be inching away. You are wasting a lot of time if you're going to only use one to move from here to here. You will pack it. There will be several of these boxes that will go here and it is continuously being removed here. That means the process is more continuous. But here the conveyor will have to be provided with more sensors, which we will talk about as an application. So this is an example of a simple latch coming into play in the area of automation. Now, if I draw a timeline diagram which shows how, with respect to an input, an output will behave with respect to an input, a timeline diagram is the best. So, X at the top is my output. The A and the B are the two inputs. Okay, so what happens? B comes on. Just short pulse. It doesn't have to be continuously true. On the triggering edge, leading edge, okay, A becomes true and it doesn't care when this goes down. It can go down after some time or it can go instantaneously down, but A will keep alive. Okay, then B comes on at the rising edge of B, this collapses. So, and if it goes down, this line can be repeated, but if it keeps going, the you cannot get X going at all. The A must be down. Not the triggering input, the latching input must go down. Okay, so that's the way the latches work, and that's the timeline diagram. The next one that plays a key role is counters, which are pretty powerful in automation. The counters can be an up or a down or an up-down counter. There are many variations. I will show you what are the different variations. Okay. Now I am not going to read this, but I'm going to explain with respect to this diagram, because that slide explains what I'm going to say. Like the latch, the counter has two inputs, an A and a B. This is a module inside the PLC, like a software hardware module. And the output from this module can be used to control an output X. You have a letter P and an R. Okay. What does it mean? R is the reset line. Some PLC calls it as the pulse line or trigger line or input line. There are many names. Now, some change this. This becomes a P and this becomes an R. So you have to be aware what the PLC is structured for. So our PLC, the one you are going to use, is not this type, is this. Okay. So what happens here? In the counter during program stage, you will store a value. Okay. Oop. Let's say I stored a value of 5. Okay. And I run the program. During programming stage, I stored the value of 5, and then I make the PLC on a run mode. The counter has two inputs, A and B. The B is the trigger, and the A is the reset. Okay. Now, for the counter to do its job, the A must be 0. That means should not be true. Should be false to start with. The reset line must be down, like the latch. So now what happens? B becomes true. Let's assume for a short time. The value here will become 4. From a 5, it will drop to 4 every time B comes on. Then B comes again for a very short time. Doesn't matter, becomes 3. Then another pulse, 2, and keeps going. When the last pulse, when it becomes 0, 4, from a 5, 4, 3, 2, 1, 0, the output will turn on. So the counter is counting the number of events that occur for the input trigger line, which is the B. Based on the value put in, the output will be controlled. So during this process of countdown, this X is 0. That means whatever that is going to be controlled will not be functioning. When this counter goes to the full counted value, this becomes 1. Okay. So what might be the use of this? The use of this, I have to be within the tablet space, otherwise I'm going to get into trouble. Okay, let's take the same conveyor example. Now I have a pallet here. Okay. And I can put 6. Not 6, 4. The pallet is what you would find in Superstore or Safeway or Sobeys or whatever. They have milk jugs on a blue or whatever color pallet where you have 4 jugs. So let's assume that's the line we are looking at. So first jug is put in, second jug is put in, then I screwed up my drawing, doesn't matter. 4 milk jugs are put in, at which time I want the conveyor to advance. So I am counting 4 here. So this value would have been a 4. Then let's assume I want this conveyor to index by turning on the output until another one stops the conveyor. Okay, so this 4 triggers this, and the next one that is going to stop is a little distance away, will stop the pallet from moving any further, giving the next set of little cartons to be put on the blue pallet. So this is a packaging line where instead of just turning it on the moment the sensor comes on, you are using this B to send pulses to this counter module, and whatever value you store, it could be 10, it could be 15, it could be 1, it could be 2, it could be 100. Okay, I can use it in a number of different ways. That's what is used in automation line. Food processing uses it quite a bit. Let's say I have 2 liter, 1 liter, 4 liter milk cartons being packaged. I can say, well, shift the line from a 1 to 2, or a 2 to 1, or 2 to 4. When 1,000 containers are done. So I use a counter to shift the line from one processing to another processing operation. That's another example. There are oodles of examples. Okay, so that's the way the counter works. Now you can read this. That's basically what I have covered on this slide. So what happens if the counter, this is how the counter operates. If this starts with a 1, you loaded the module with a value, but let's say here this is the A that is going to stop. It's true. That means there is a box sitting here. No matter what happens here, you put 4 cartons or 4 jugs into this pallet. So B becomes true. This will lock it from moving. That means the process can't go until this clears. Right? So you can control simple, complex process using this. Now, I talked about the carousel control in the airports for baggages. They were not really automated long ago. There was somebody out there who is throwing your boxes from the aircraft into a little trolley, and the trolley comes to the airport location, and they are empty, and then they press a button to get the conveyor going. Now there's a lot of automation. Okay, so you drop. There are 3 layers of conveyor connected to each other, one at a higher height, and then it comes to the ground level. They are all synchronized. They can stop the line. If there is a jam, they can slow the line if too many boxes are not taken out at the carousel, so that when they come down, especially if you had packed enormous lead weights into your box, you can crush the one below on the carousel when it comes down tumbling. So now there is a lot of automation present in that process. Any packaging line, anybody who is involved in packaging from Amazon, I'll show you one a video of one line. After I complete all these lectures, you will be amazed at the amount of automation that goes on the line. The other example, the Singapore Airlines is probably one of the best in terms of implementing technology. The whole airport operates using a lot of automation. Singapore airport caters to a wide variety of global movement. So people, when they drop their luggage at a central location, the barcode is used very powerfully to route your baggage automatically to the correct terminal as well as the gate where your aircraft is going to take off. Nobody is going around putting it in different trolleys. Everything is pretty automated. Okay? Now, if not implemented right, automation can lead into all kinds of problems. Like the super value case that I showed need not have happened. But one of the recommendation after doing a lot of analysis is the line was about 20% faster than what the human can handle. Okay? So the human was pacing and not really observing what is going on in the line. So the ideal speed that was recommended is 24 feet per minute, not 30. But presumably this came out afterwards. Super value lifted it up from 20 to 30 because they wanted to do more packaging. So they did tamper with it, but this came after the case was finished. Okay? So automation, if not done properly, can be a big problem. So the counter timeline diagram, B is the trigger line, 1, 2, 3. This is the third time. Let's assume I stored a value of 3. So what happens? Rising edge, rising edge, rising edge. Now, should this output X be here? The rising edge, then come down when it comes here. So it is on for this time. Or should it be on the trailing edge? Okay. Different PLCs operate differently. Okay. So you have to know how the counter works. So right now, take this diagram. When I show you the demo of the PLC of all these functions, you will see whether it is going to be triggered on the rising edge or on the trailing edge. So the rise or the trail is important. Plus, it's can be a pulse. It doesn't have to be continuous. For example, what happens here? If this stayed for a long time and then went down, it doesn't matter. It got triggered here. The value became from 3 to 2 and stays as 2. Nothing happens here. And then when it goes down, nothing happens. The next time it comes again, it becomes a 1. And so on. So best is to see the demo and understand this more thoroughly. So I introduced this timeline diagram. Now I'm going to formalize it because I'm going to use it in my next case study. So basically, timeline diagrams are diagrams which represent a process with respect to time pictorially. And this is what is recommended you do whenever you are faced with a problem for which you are going to produce a logic solution. These are the key steps. Number one, understand the problem completely as to what is required to be automated. Second, put logical statements on the basis of some inputs and outputs that are going to control the process. Plain English. Then put the truth table. Analyze. You, the designer, analyzes the truth table and decides on when the output should be true or not true. Develop the equations. And if they are too cumbersome or unwieldy, compress it using theorems and so on. Then you have a set of equations. How do you know they are correct? Best is, before you go to the PLC, draw a timeline diagram to see whether the timeline diagram exactly shows you how the process is going to behave. Okay, so here is an example of the timeline diagram for the conveyor system that I used, the automatic weigh station. So basically what happens in this conveyor system or the timeline diagram. Okay, so there are two outputs. No, there is one single input and one single output. Okay, so let's assume this is this variable x represents a defective part when the trap door has to open. So here a defective part was triggered. So what should happen? The trap door should open right away. So the defective part is traveling. Okay, and you are going to predict about 1, 2, 3, 4. 4 seconds is required normally for the part to travel from the weigh station to barcode label station. That you have to predict. If something happens in between, if there is no feedback, you would not know. So you program this on output to stay for 4 seconds because the barcode is a little bit beyond the barcode reader is ahead of the trapdoor. So whatever, you know what I mean. The trapdoor should open for 4 seconds, letting the part go to the reject pin, and it should automatically bounce back. There is no feedback whether this part has traveled all the way. In this simple case, in the ideal case, you will have to put more sensors. Then it bounces back at the end of 4 seconds so that the next part, if it is good, it'll travel over to the delivery station. Timeline diagram kind of pictorially represents the process. Timeline diagram can also be used to analyze logic equations. So here is a case of an AND circuit. If A and B are true, generate an output C. That's an AND operation. So pictorially, A, B, and this is the output C. B came on, A was not there, B went down. Then A came on, went down, no output here. Then at this point A came on, B is not there, but after a short time B also came on. So during this period only A or B was there, but beyond this, on this zone, both are true. That means logic C should fire. The output came on and then suddenly one of them collapsed and it goes on and on. Okay, so simple timeline diagram explains how the process behaves. So I have introduced a timer, a counter, a latch. Now I'm going to put through some examples that are going to make use of one or the other. And this time I'm going to show you a different way of approaching the problem without truth table, but later on I'm going to show you what the truth table would be for that process. Okay. So I'm going to take the case of a ventilation system. The simple example I would give you for a ventilation system, I don't think any of you attended university at a time when in classroom the media that was used to project two styles right on the board or use transparencies, pre-done transparencies, or you write on transparency sheet and keep a huge bundle of transparency sheet which has to be hand cranked on a overhead projector. Did any of you go through that? No? Okay. I have used it, I would say, until about 15 years ago. And for the last 20 years, I have been only on an electronic mode with writing on the board, plus transparency, but my major presentation mode is electronic. So if you had seen those projectors, they have a huge, a very powerful bulb, halogen bulb, projector bulb inside, which generates a lot of heat. Okay, they are about 500 watts or whatever, I don't remember. So they will burn out very quick if they are not cooled. So there used to be a fan at the back. The moment you switch on the projector, the fan will come on and the bulb will come on. And the fan will keep going as long as you're using the projector. Then the fan will go down when you switch off the projector. Not good, because there is a lot of residual heat built up inside the projector chamber, but that's how it was. Now, if you look at the modern overhead projectors that we use to link up our laptop and go to the screen, they are a bit more sophisticated. They also use very powerful, very expensive bulbs. Those bulbs are upward of $100 to $200, who knows. So those bulbs have to be cooled also. So there is a fan built into the console. Now, it operates like this. When you switch on the overhead projector, the bulb doesn't come on right away. Bulb takes a couple of seconds or even 1 or 2 minutes before it will come. It also looks whether the shutter in front is closed. If the shutter is closed, the projector bulb will not turn on. Okay? So the shutter, of course, is always open because somebody maintains them. Then when the bulb comes on, you use it for 1 minute or you use it for 60 minutes, doesn't matter. At the end of 60 minutes or 1 minute or 10 minutes or 15 minutes, no matter what, how much heat is generated inside, the fan at the back will keep going for a period of time, allowing purging of the hot accumulated heat inside the sensitive electronics and the bulb to be brought to room temperature. Okay? So, simple process. How complex is the logic going to be? That's what I'm going to show you. So, the problem statement is process requires ventilation while the machine is running. as well as for a period of time after the machine is shut down. After a period of time. So a timer is going to be involved. Requires ventilation fan. Output needs to be generated while the machine is running. What is going to cause the machine to run? Some input. So you have an input, a timer, and an output for a very simplistic problem. It can be made more complicated. I will tell you after I finish this problem. So identify, I already written on the previous slide, an input, an output, and a timer. So input, on-off switch. Must state the type of switch. Is it a pulsed switch or is it always kept on like your room power, room light switches? Now, in this case, I'm going to assume that it is like a room light switch which stays on or off depending on what you did. Okay? So output, a fan. Well, going back to the previous slide, I said output. Looks like outputs. Ventilation. Oh, my geez. So, I don't know why my pen should keep going down. Okay. So, this is output 1. Okay. That's a fan. The process. Output 2. Okay. So, we are now going to expand. Output is fan and machine. Input is on-off switch. Then, I also stated in the problem, fan must be on for 3 minutes after the system switch has been turned off. A timer is coming into the picture. Okay, so this is the statement of the problem. Can we go to the truth table or can we go another route? I'm going to show you the another route and then come back to the truth table. Any questions? I'm almost got only 1 minute left, so I'm going to stop here. Any questions on anything? So for this afternoon's lab exercise, we're going to continue with project 2. I will know exactly, I will take all the files that have been sent, so I would know who is still left, but it doesn't matter. You should have gone into project 2 already, which I know you have. I would like you to look at the D2L Word file that I have submitted, or a PDF file, and use that information on project 2. I will be there. I will be operating out of the lab, not from home. And any other question you may have, you can ask me at that time. If when I ask whether you're able to remotely link with the IDEC PLC, which is the WinLoader, the software will be called WinLoader, let me know. I'm very anxious to know about it because your project 3 and 4 will rely heavily on that software. Okay, that's
Hey,
it for me.
Professor,
Yes.
are you still planning on having us come in for the machining for projects 2?
Yeah, this is how good you asked me. This is how I want to do it. Before midterm break or on or before, if you give us the file, we'll review it. And then when we cut, I will tell you when we will cut, or based on your availability, we will do it with you watching rather than go through video link. Yes, I would like you to come. Unless you have some objection about it.
No,
So
that sounds good. Thank you.
Yeah. Both options will be made available. Okay? That's it for now.
Thank you.